Hey guys, it's Ms. Johnson and I'm here to bring you our notes for Unit 6 Learning Target 4. Today we are going to go through some exponential word problems. So we're not going to really learn a whole new concept today. We're just going to talk through how we would read a specific word problem and how we would then address and answer it. All right, so let's take a look at number 1. It says movie ticket sales decrease each weekend after an opening. The function E equals 49.9 times 0.692 raised to the W. Models, that's supposed to say models there. Models the earnings of a popular movie. In this equation, E represents the earnings in millions of dollars and W represents the weekend number. Estimate how much money the movie made the first weekend. So if we are trying to figure out how much money the movie made the first weekend, first of all, we're given an equation. So that's the first thing. We have an equation. We know that we can use that equation. We know that W is our independent variable here. That's the variable that we need to find some value to plug in for. So if I am looking at W represents the weekend number. We are looking at the first weekend. That means W is going to equal 1. It's the first weekend. So if I take a 1 and I plug it in for W, it looks like this. E equals 49.9 times 0.692 raised to the first power. So then I would go through and I would type that into my calculator. If you haven't gotten your calculator out yet, go ahead and grab that now. So 49.9 times 0.692 raised to the first power, and I get 34.53. E equals 34.53. Now, one thing I will say is I'm not going to circle this as my answer. This is a question with words. So if it's a question with words, that means it needs an answer with words. What I'm saying here is that anytime you have a word problem like this, you have to label your answer. So my answer here would be $34.53, and that's in millions. So I'm going to say $34.53 million there. Okay, so just me putting in the dollar sign and the fact that I marked that it's a million, that gives me my answer with words to go along with just the mathematical equation that I solved. All right, let's take a look at number 2. In number 2, it says some people say that the value of a new car decreases as soon as it is driven off the lot. The function V equals 25,000 times 0.82 to the T power models the depreciation value of a new car, and T represents the time in years from, that's supposed to say from, sorry, the time of purchase. Estimate the car's value after 5 years. So we're looking at a car and we want to know how much has it depreciated, meaning gone down in value, 5 years after it has been owned. So I'm again going to use the equation that I was given to me. Anytime you're given an equation, use the equation you have. There's no need to change it or write something new. You have an equation, so you need to use that equation. I need to plug something in for T. I'm told that T is time in years, and I'm asked to find it after 5 years. So that means my T is going to equal 5. So here's what my equation looks like. V equals 25,000 times 0.82 raised to the 5th power. And again, I'm just going to type that into my calculator. 25,000 times 0.82 raised to the 5th. And I end up with 9,268 and about 50 cents. So again, there's my result mathematically. There's me simplifying this mathematical expression, and there's my answer. But again, I have a question with words. All of these word problems are going to need labels with their answers. So I'm talking about the value of a car. This is in dollars. So I would say $9,268.50 with my dollar sign there. That's enough to label my answer so that the context of the problem is given. Let's take a look at number 3. The value of company's computer equipment is decreasing according to the function y equals 4,000 times 0.87 to the x power. In this equation, x is the number of years that have passed since the equipment was purchased, and y is the value in dollars. What is the value of the equipment 5 years after it is purchased? So again, this is another kind of depreciation type question where you buy a new piece of equipment, and we all know that once you buy that new thing, it doesn't stay with that original value for very long. It doesn't matter what it is. It could be something small, it could be something big, but the original value is lost after a period of time once you purchase something new. So this is another question of like depreciation. Again, x, here's my x, that's my independent variable. That's the variable that I need to fill in some value and then simplify. In this case, x is number of years. The number of years I'm asked for is 5, so my x is going to equal 5. So I've got y equals 4,000 times 0.87 raised to the 5th power, and I plug all that in, and I get $1,993.68. Question with words, answer with words. $1,993.68. Put your dollar sign so that you have a label on your answer. Let's take a look at number 5. It says, suppose the waste generated by non-recycled paper and cardboard is approximated by the function y equals 1,000 times 2 to the 0.3x power. Estimate the waste generated by 5 pounds of non-recycled products. So x is going to be pounds in this scenario, okay? So the pounds of non-recycled product are going to go in here for my x. Now here's what looks a little bit different about this equation. So when I look at this equation, there are 2 things up in that power position. There's a 0.3 and an x, and they're being multiplied together. So here's how I'm going to type that in. I have y equals 1,000 times 2, and then it's raised to the 0.3 times 5 power. So here is what makes this one different. The first thing that you have to do in this one, if you think about order of operations, we have to take care of grouping symbols first. So we do have some grouping going on here up in that power position. I need to take that 0.3 times 5 and put those 2 things together. So 0.3 times 5 gives me 1.5. So now I can use that as my power and type everything else into my calculator. If you do not do this part first, what your calculator will likely do is it will likely raise the 2 to the 0.3 power and then come down and multiply by 5 after, and that is not what you want it to do. You need these 2 things to be together. So it's very much to your benefit to multiply those 2 things separately together first. So just take 0.3 times 5 in your calculator first, hit enter, then use that number to go through and type the whole thing in. So now I'm ready to type in 1,000 times 2 raised to the 1.5 power, and I get y equals 2,828.43, and this is in pounds. All right. Let's take a look at number 5. In number 5, we're looking at a table and we're asked if this chart shows exponential behavior. So let's talk about how we would do this. The first thing that I need to recognize is that my x's are increasing by the same amount each time. I go from 0 to 10, then 10 to 20, then 20 to 30. So good, I'm good there. X's increase same amount each time. Okay, so then what I'm going to do is I am going to, if this is exponential, that means that I'm multiplying by the same factor over and over and over. That's what the definition of an exponent is. It's repeated multiplication. You multiply by the same factor over and over and over and over again. So if that is true, if that is the case, that means that if I undo that multiplication, if I take this 156 down here at the end, and I divide it by 6250, I should get the same answer as if I divide 6250 by 25 and then 25 by 10. So that's what I'm going to do. I'm going to say 156.25 divided by 62.5 and see what that is in my calculator. 156.25 divided by 62.5. I get 2.5 here. Okay, so that's kind of my factor that was multiplied to get that 162.5 or 156.25. Okay, now let's do it again. I'm going to go 62.5 divided by 25, and I should get the same result. And I do. 62.5 divided by 25 is 2.5. Okay, so that's good. That's a good sign. The first two are the same. Now let's check the last one. 25 divided by 10. And most of us can do that in our head. Just move your power over, but you can use your calculator. So 25 divided by 10 is in fact 2.5. So because all of these are the same, yes, this is exponential. And again, I would say that that is true because we used the same multiplier for y. Okay, so I used the same multiplier for y each time, and that's what makes my exponential behavior. Now let's take a look at one more chart. So again, I'm going to check my x's. That has to be my first thing. So do I increase the same x each time? Yes, I do. 0 to 1, 1 to 2, 2 to 3. Okay, great. Now I need to do the reverse on the y's. I need to divide. So 0.125 divided by 0.25 and see what I get. 0.125 divided by 0.25 and I get 0.5 there. Then do it again. So 0.25 divided by 0.5, 0.25 divided by 0.5, and I get 0.5 again. 0.5 divided by 1, we should know this, is going to be 0.5 anytime you divide by 1. So once again, I have the same multiplier each time, so I would say yes, this is exponential. All right. Okay, so that takes us to the end of our kind of exploration of word problems here. Thanks for tuning into our video for today, and I will catch you next time.